Here, the statement of the problem says, simplify completely. Therefore, it means that when we are through, the expression so formed should not be able to be further simplified. Simplify completely. What we have here is an algebraic fraction that is to be divided by another algebraic fraction. So we are handling the manipulation of algebraic fractions. The operation that is required is division. And like in any other branch of mathematics or for any other set of fractions, when we are dividing by a fraction, irrespective of whether it is an algebraic fraction or a simple vulgar fraction, the treatment is the same. If we are dividing by a fraction, then we will multiply by its reciprocal. So that is the first thing that we are considering. We are considering that we are dividing by a fraction which requires that we multiply by its reciprocal. So there we have the two fractions, and we are dividing one by the other. The first fraction is the dividend, the second one is the divisor, and we are going to, well, the divisor is the one that we are dividing by. That is the one whose reciprocal we should multiply by. So there we have our division sign. Dividing by a fraction may be achieved by multiplying by its reciprocal. And another name for its reciprocal is multiplicative inverse. Multiply by its multiplicative inverse. So there we have it. Simplify by a common factor of 4. So we can see here that we have in the numerator and denominator factors of 4 by which we may simplify. So since we have a common factor of 4, then we may simplify by a common factor of 4. And of course, we may also simplify by a common factor of 3. We have a factor of 3 in the denominator, and of course, an obvious factor of 3 in the numerator. So simplify by a common factor of 4. 4 into 4 is 1. And 4 into 20 is 5. We have that coming up in our caption in a few seconds. And we are simplifying now by a common factor of 3. 3 into 21 is 7. And 3 into itself is 1. And of course, we have our large statement saying that when we divide 4 by 4, the result is 1. When we divide 20 by 4, the result is 5. When we divide 3 by 3, the result is 1. And when we divide 21 by 3, the result is 7. We could simplify the expression further, but it would be too cumbersome. So we could go here, and from this position that we are at, do a further simplification of the expression. However, because of the first two steps in simplification, we have quite a few expressions and numbers and the rest of it. So we will not attempt a further simplification right here. So we could simplify the expression further, but it would be too cumbersome. Let us write the simplified form. So since we have taken those two steps, what we are going to write now is a simplified form of the original expression. And there it is, because 3 is gone from the numerator, and also factor of 4 into 20 is 5, and the y squared is unaffected in the denominator. 4 is gone. The y cubed is not affected. Factor of 7 is taken from the 21, and of course the x squared is not affected. Now we will do the further simplification. So we will continue the simplification of the expression. Notice that we have occurrences of x in the numerator and the denominator, and we have here the entire thing spelled right out in the way that it is. Just a single occurrence of x in the numerator. In the denominator, we have x squared, which is merely x times x. And what will happen? Right. One occurrence in the denominator will cancel with the one in the numerator, and all that we have left is x in the denominator. Now, what we have here, y squared in the numerator and y cubed in the denominator. Y squared, two occurrences of y, y times y in the numerator, y cubed, three occurrences of y in the denominator, y times y times y. So what will we have? Let's see. Those two in the denominator will cancel with 2 in the numerator, and all that we have left is one occurrence in the denominator. There we go. If we take a look at the entire thing, the 5 7s will return, and the simplification by the common factor of x will result in 1 over x that we had right here, and the simplification by the common factor of y will result in 1 over y that we showed right here. All we need to do is put all of those together, and we'll get 5 times 1 times 1, that will give us 5, and then 7 times x times y, that will give us 7xy. So the final result is 5 over 7xy. That is our final answer. When simplifying expressions, we do not intend that you should show all of those steps. They are only expressions of how the process may be understood. We expect that you will do it mentally. So although we are demonstrating and we are showing intermediate steps, you are not required to show those steps in an examination. What we have here on this slide is a demonstration of the processes of simplification that you may follow, not that you need to show them in an exam. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.